Hello, knowledge seekers. Welcome to Remedial Tutorial Academy. In this math function lesson, we'll break down concepts step by step to make problem solving easy and clear. Let's get started. In this video, we're going to focus on relations and functions. So what is a relation? A relation is a set of pairs of input and output values. Here, we have three ordered pairs in the first relation on the left. The x value is the input value. The y value is the output value. The x values is associated with the domain of the relation. The y values is associated with the range of the relation. So now let's focus on part A. List the domain and range of each relation. So let's start with the domain. So what we're going to do is we're going to make a list of all of the x values, and I'm going to write it in ascendant order. So first, we have -3, and then 0, and 2. Now let's write the range of that relation. So we're going to focus on the y values, and it's already listed in ascendant order. So 1, 4, and 5. Now let's do the same thing for the other relation. So let's write out the domain. So the lowest x value is -2. Next is 1, and then 3. Now let's write out the range of that relation. The lowest y value is -2, and then it's 3, 4, and 7. So that's how you can write out the domain and range of each relation. Now, how can we determine if the relation is a function? In order for the relation to be a function, every input value must have only one output value. If an input value corresponds to 2 or more output values, that relation is not a function. Now let's focus on the first relation. So we have the ordered pair 2, 1. The input value is 2, the output value is 1. And then -3, 4. So -3 corresponds to 4, and then 0 corresponds to 5. So for the first relation, we can see that for every input value, there's only one output value. Now let's focus on the second relation. So we have the ordered pair 1, 3. Next is -2, 4, and then it's 3, -2, and then finally -2, 7. So for the second relation, notice that -2 corresponds to two different output values. Now that's a problem. If you put in an input value of -2, should the output be 4 or 7? So whenever you have that situation, you know that relation is not a function. The first one is a function. Every input value corresponds to an output value, just one output value. So a quick way to look at a relation to see if it's not going to be a function, look for repeating x values. If you see two x values that are the same but correspond to two different y values, then you know the relation is not a function. Let's move on to the next example. Draw a mapping diagram of each relation shown below. So let's start with the relation on the left. We're going to map out the domain and a range. So for the domain, we have the values -2, 1, and 3. For the range, we have the y values -6, 0, and 4. Now -2 corresponds to 0, 1 corresponds to 4, 3 corresponds to -6. So for every input value on the domain side, there's one corresponding output value on a range side. So this is a relation. This relation is a function. So the answer is yes for the first relation. Now let's move on to the second relation. So let's create a mapping diagram as well. So let's start with the domain. The lowest x value is -2. Next we have 0, and then the last one is 3. Now looking at the y values, the lowest one is -1, and then it's going to be 1, 2, and 5. So -2 corresponds to +1, 0 corresponds to 5, 3 corresponds to 2, and 0 corresponds to -1. So just by seeing the repeat x values that we see here, we could tell that this is not going to be a function. The two x values have two different y values. You can see 0 points to -1 and 5. So the second relation is not a function. Now for this one, what we're going to do is we're going to draw a function table of the relation, and then we're going to determine if the relation is a function. So in this table, we're going to list the input values next to the output values. The input values represent the x values, the output values represent the y values. So the input values, it corresponds to the domain, and the output values corresponds to the range. So the lowest input value that we have is -3. Next is 1, and then we have another 1, and then after that is its 3 and 5. Now for this function table, I'm going to write the input value twice because that's what we have here. When writing out the domain and the range for repeat values, we would write repeat values once. Now -3 corresponds to 2 for the table. These numbers need to match, so I'm not going to list the output values in ascendant order. Now for this one, we could use either one, so I'm going to use 1, 2 for the next one, and then 1, 4. Now when x is 3, y is 7, and when x is 5, y is negative. So that's the function table. And because we have two identical x values that correspond to two different y values, we know that this relation is not a function. So that's it for this problem. When you have a graph, the best way to determine if the graph represents a function is to use the vertical line test, and that's what we're going to do in this problem. So any way you draw a vertical line for the first graph, notice that the line only touches the graph at one point. Therefore, this is the answer is yes, it represents a function. For the next one on the right, if we draw a vertical line, notice at this point, or place a line at that location, we have 3 points of intersection between a graph and a vertical line. If we can get 2 or more points on a vertical line, then a relation is not a function. So we're going to say no. Now if we put the vertical line here, notice that we have 5 points on that line, so this relation is not a function. For the next relation, it doesn't matter where we put the graph, we will only get, doesn't matter where we put the vertical line, we're only going to get 1 point. If we put it here, it's only going to touch the line once, so we can't draw a vertical line where it touches 2 points. Therefore, this relation represents a function. For the circle, if we put the line here, we can get 2 points of intersection, so we're going to say yes. No, not yes. This is no. The circle does not represent a function. It does not pass the vertical line test. It touches the line at 2 points. In order for it to pass the vertical line test, the graph must touch the line only at 1 point, as we saw in these two cases. So that's how you can use the vertical line test to determine if a relation represented by a graph is a function. Thanks for watching. I hope you enjoyed. Please comment down below what other topics you'd like for me to review. I upload new videos every day. Don't forget to subscribe and share for your friends and classmates. See you next time.